All right, guys, 1.10, equations and functions. We're going to get started with some vocabulary. We've actually been doing this a long time with function tables, but now we're going to add a little bit more vocabulary to it in the terms of domain and range. A function is a relationship that assigns one output for each input. We look at that as mainly being the function rule, and that's an operation performed on an input. Okay, and so what we put in, we do the function rule to it, and then we get an output. And this goes with the relationships that we saw with the expressions that we were writing yesterday in our sequence tables. One thing we're going to add, though, is these two vocabulary terms. And the first one is domain, and then domain is another name for the input. Okay, and so if we took that information and we put it on a graph, our domain would be the x. All right, so what are we putting in for x? Our range is our output values, or the y on the coordinate graph. All right, so something plus x or times x equals y, and that's kind of what we're getting to with our equations, is that one is going to lead to another. Okay, x is going to lead to y. Our domains lead to our range of answers. The domains of what we put in lead to a certain range of answers. So you can kind of see how that works out. And as we look at some of these tables, hopefully some of that makes sense. So here's a word problem that says Javier saves $20 each month. Make a table to show savings after 1, 2, 3, and 4 months. What is the domain? What is the range? So we got a lot of information we're going to put in here. The first thing we're going to do is look at our inputs. And our inputs for this are 1, 2, 3, and 4 months. All right, so those are going to be our inputs. Now, it says he saves $20 each month. So after 1 month, we know he's going to have $20. We know that after 2 months, he'd have $40. If we add another 20 to that, he's going to have $60. If we add another 20 to that, he's going to have $80. Now, we were looking for function rules, and that's what's actually happening here between our input and our output. So if we took our x, what would we have to do to x, which is our input, to get it to be 20? Well, I know that 20 times 1 is x, or excuse me, 20 times 1 would equal 20. So I'm going to start out with 20 times x equals y, which would be our output. Now, I want to know if I can keep this rule. Can my rule be 20x equals y? Well, if I put 20x here and that equals y, let's see. 20 times 2 is 40. Does that equal y? Yes, it does. What about for 3? 20 times 3, does that equal 60? Yes, it does. What about 20 times 4? Yes, it does. All right, and so that gives me a range of answers of 20, 40, 60, and $80. Right, and so our domain affects our range, and these coincide with each other. And again, when you have rules, typically with the things that we are working with, one input is going to lead to one output. What we'd eventually have is 20x equals y as our overall rule. And if they had more than just the 4 months, any month that we put in for x would follow this rule. 20x equals y, and that would give us whatever our y is. So we'll look at that more in the next couple of days. Should be fun. I like doing this, and I like getting to the point where we can put this stuff on graphs, so it's pretty neat, in my opinion.